We will start with a quick review of high voltage surge, which can affect any electrical components either in the condenser or the air handler. On the inside, these could include the thermostat, any wiring, the transformer, furnace control board, or that blower motor. In the outside unit, those surges could affect the capacitor, the contactor, more wiring, and the defrost control board, as well as the fan motor. But we can't forget about the compressor, which is the costliest component that may be affected. When surge does affect the compressor motor, it usually is not visible, and only a licensed technician with the proper testing tools can make those determinations of damages. Next, we're going to review theft and vandalism, and these first two photos tell those stories perfectly, from stealing the coils for copper to writing a name in the coils, probably just for fun. This photo shows more signs of theft and just how desperate those thieves can be when they are cutting the copper pipes all the way back to the compressor and even cutting and taking all the copper wires. And of course, these units are not immune from fire, smoke, and water damages, all of which are usually to the inside air handler. These would pretty much be the same as reviewed for furnaces. Be sure to consider the type and amount of smoke and whether cleaning the unit and replacing the filter might be the proper repair method. In some extreme cases, a full replacement may be required. Here are two photos that look almost identical. This was a water loss scenario with multiple units of similar makes and models. So, can you tell which one was damaged by water? Don't feel bad. I can't either. So in cases like this, the water damage is not visible and the system would need to be tested. So in this, it turns out the one on the right was damaged by water and many of those electronic controls had to be replaced. The one on the left was actually non-damaged. Since heat pumps have an outdoor condensing unit, that component is going to be a target for weather-related hazards. Hail is very common to condenser units, especially those units with unprotected coils as seen here. The repairs on hail damage could range from combing the coils with very minor hail impacts to a coil replacement with heavier damage as seen here. Full replacement is not usually warranted in a hail claim. Wind can also cause damages such as tipping the condenser units over as seen here. This could damage the unit and kink or break both the line set and or the electrical whip. And windstorms could also cause falling trees or large branches that hit the unit and cause damages. This unit will have to be replaced due to the level of damage, but that does not mean that all the inside equipment needs to be replaced as well. That will depend on the type of refrigerant the system is using and the configuration of the inside equipment, as well as probably efficiency. Wear and tear is a large part of what we see with heat pumps, so we'll review the top 3 wear and tear items that kill these systems. Our first one is resistive heating, which is damage at or near connections that for some reason have built up high resistance and causes the wires to overheat, which can char or even melt the wires and wire insulation. So what causes this buildup of resistance? One causes rust and corrosion. Notice that rusty screw connection on that heat pump contactor and the resulting damage as the wire continued to overheat over time until it finally failed with charring, melting, and corrosion of the connected wire. The other common cause of resistive heating is poor or loose connections. See the damages on those capacitor wires near those slip-on connectors? That is not lightning or surge damage and did not happen suddenly or accidentally. This type of damage happens over time with hundreds of on-off cycles of the unit. Also remember, resistive heating, especially from rusty or loose connections, is almost always within 1 to 2 inches of the connection. Our next wear and tear damage is caused by acidic refrigerant. Shown here is a technician holding a brand new acid test kit. Notice it is yellow. The tech then runs refrigerant through the tube at the service valves. If that yellow pH paper changes colors to reddish orange, purple, or even pink as seen here, it shows there is acid in the refrigerant. Please note, refrigerants and oils only become acidic over extended period of time due to moisture, mixed refrigerants, or other contaminants. Many times from refrigerant leaks. A lightning strike or surge event occurs instantaneously and cannot acidify the refrigerant or oil in such a short period of time. Dirty coils are the third and final wear and tear item that is a slow killer of AC systems, especially the compressor. Dirty coils could be either outdoors, indoors, or both. This is strictly a maintenance issue. Outside coils need to be cleaned regularly by spraying them off with a hose, but be sure it's not a pressure washer as that could cause damage. Inside coils are kept clean by the filter, and those filters need to be changed regularly to maintain a clean evaporator coil. If we have dirty coils, the system won't cool properly. The dirt, dust, and debris acts as an insulating blanket that impedes the heat transfer and the phase change of the refrigerant and adds undue stress on the equipment, causing the motor, windings, and wires to overheat. It also reduces airflow through the coils, which compounds the issue. Next, we're going to look at a couple heat pump claim scenarios.